Of the videos I've made, the workshop tools seem to be the most popular, so here we have a few more you may be interested in. First off, we have a homemade poor man's cutter grinder. I'll just pan back a bit, wrong way, whoops. And as you can see, I'm using a bench grinder which is bolted onto a very firm bench. This is all steel. You need absolute rigidity here, and you need no end play in the wheels. I've packed these out. It's a cheap grinder, but it's a way over the job. And here's one of two tool grinding attachments I've made. Here we have the tool holder, and it's on two dovetails at right angles to one another. The advancement of the tool is on this thread, and the tool is worked backwards and forwards by this handle here on a cam. Bit stiff, hasn't been used for a long while. There we go. Trouble is, grit gets into the slideways. I learnt by the time I made this one and turned the slides the other way up. But it's a very simple device. Needs must, one poor man's cutter grinder. It's possible, even with this simple setup, to achieve quite good results. I'm quite pleased with it, really. This is the second grinder I made on the other side. Still having troubles with this camera. Went out and bought the latest digital, all singing, all dancing. It doesn't compare to this little Panasonic. Anyway, we'll persevere. We'll move on. Here we have a cheap and these tools are false economy. They look quite good, but the shortcomings very quickly develop. In this case, the motor burnt out in no time at all. The threaded parts of the handle here, the threads, I can only describe as monkey metal. Stripped, and I've had to weld them. The plastic knobs on the end, they were so flimsy, they kept coming undone. When you tightened them up, they fell in two halves. Quite ridiculous, really. Even the column, which is cast, they'd left a core plug inside. And when I turned the machine upside down, I must have had half a kilo of sand fall out. If I'd wanted a sand castle, I'd have bought one. But most unbelievable of all is that the table broke. It was full of inclusions and was absolutely useless. I won't use the words I want to. So here I've got a 1.25 inch, I suppose, end flange pipe flange. And I've mounted it on a heavy section of C-angle iron. And although this is tiltable, I've set it up with some drill rod in the chuck, a set square and a light behind, and got it as square as I can for something of this quality. And it actually turned out quite well. It's solid, it's flat, and I've made use of the holes around the outside. I've turned up some simple plugs that drop within the holes. So if you're turning something by hand, although theoretically of course you should bolt everything down to the table, but if you're just doing a quick job, something thin, to stop it riding up the drill or coming round and smacking your fingers, this is quite handy. So that's an improvement, but one shouldn't have to do this, of course. I keep buying these sort of things, thinking that I can readapt them, re-engineer them, but it really doesn't pay, it really doesn't. It's far better to have a few good quality hand tools than a workshop full of this stuff. Here we have a floor standing drill, far superior quality. I like this one. I actually pulled it from a skip. An engineering firm went bust, and judging by what they've done to it, I'm not surprised they went bust. They've treated it diabolically. I'll see if I can pan onto the table. Zoom in a bit. There you go. There was a whole series of holes right the way across here. Dimples where the operator had clearly fell asleep and decided to drill through the table. I think a couple of the knobs were missing, and the switch was a bit iffy. But no, they threw it out. Crazy. So what I've done here, I drilled out the dimples and I drilled out the holes with a larger hole, and then I slightly countersunk the holes, only by about 1/16 of an inch, not even that. And then I lathed up some material, an interference fit into the holes, and tapped in the rod until it was just proud of the surface. And then with a small ball peen hammer, I peened over the surface to upset it into the countersink, and then I ground it off. And I'm very pleased with that. Cost me nothing out of the skip. And need I say, made in Great Britain. Because this came from an industrial source, it was of course three-phase motor. And what I've had to do, providing you can get at all 6 wires of the 3 windings of a three-phase motor, I've rejiggled them around from star configuration to delta and placed a capacitor across one of the windings and applied single phase power to one of the other windings, and it works very well. Converting 3-phase motors like this means you probably end up with 20-25% less torque than you would have done with a 3-phase. 3-phase motors, after all, are far more powerful size for size than single phase. But they're used in an industrial environment. They're used in hot, continuous conditions, and the average home workshop won't notice any difference. I did exactly the same with the motor in my lathe. I'll see if I can pan this round. Well, I can do if I can do that. This is my Colchester student lathe. I converted this from 3-phase to single phase. Works very well. I particularly like the brake on this. Stops instantly, which is very handy if you're doing a thread up to a shoulder. This was made 3 miles up the road from where I live now in Colchester, Britain's oldest recorded town. As I was born in 1943, and I don't suppose this lathe is that much younger than me. It's given me great service, and it's built like the proverbial brick small house. I had to put a suds pump in. I make my own suds, by the way. It didn't have one, and I used a lorry windscreen wiper washer motor with a transformer because it had, and a diode because it had to be DC, of course. And it works very, very well. Colchester lathes are no longer made in Colchester, of course, all finished, all gone down the pan. No industry or foundries left at all. All been sold out, unfortunately. The site now is just full of tacky little houses. But there we are. I mustn't start moaning. I'll show you a little item I've made. It's a 4-tool turret, which I very rarely have more than 2 tools in. I can lift that off. I've made another little turret, which I've set, I won't bolt it down, but as you can see I've set up parting off tools. And they're already packed out and set for centre height. So that's a quick and easy means of popping that on if I want to part off something I've made. I make several of these things because they're already set at the correct height. That's a simple little arrangement. Another simple arrangement I have is I'll put this on as a stop. So when the saddle comes along, it goes up against the stop, and I can put a clock dial in there for items that require repetitive machining. Very nice machine. Here we have a little tip you might find handy. This is my milling machine, and the vise usually sits in the middle of the table. And what I've done here is I've made a plywood cover for the table. It's cut round the vise, both sides, and it sits on top of the bed and keeps this nice and clean. It stops a lot of the swarf from going into the T-slots. It's just a matter of lifting up the ply and emptying it into the bin. Very simple little tip that, but it can save you a lot of time. If I'm drilling large holes in the lathe, I'll use copious quantities of suds, a slow speed and a slow feed. But if I'm using it here on the drill, I'll use a cutting compound. Oh, my battery's going. More for another time. Thanks for watching.